Welcome to Dark Sky Dive, where we plunge into the cosmos to uncover the true nature of the giant planet Jupiter. Most textbooks describe it as a gas giant, but recent discoveries suggest this label is entirely misleading and scientifically inaccurate today. We are about to embark on a deep dive into a world that is actually a colossal sphere of liquid metal. To understand the true structure of this celestial titan, we must look beyond the surface clouds and penetrate the deep interior. The scale of Jupiter is hard to comprehend, as it is massive enough to hold 1,000 Earths inside its volume. It is the king of our solar system, possessing twice the mass of all the other planets and moons combined together. Billions of years ago, this giant formed from the primordial dust and gas that remained after the birth of our Sun. One theory suggests it began as a rocky core that grew large enough to capture massive amounts of hydrogen and helium. This process of accretion allowed Jupiter to become the dominant gravitational force, shaping the destiny of the entire solar system forever. Another compelling hypothesis proposes that Jupiter formed directly from the collapse of a dense cloud of gas, skipping the core phase. Regardless of how it started, the result was a world of extreme proportions, distinct from the rocky inner planets we know. For a long time, astronomers could only guess what lay beneath those thick, opaque clouds that shroud the planet in mystery. Observations from Earth were limited, providing only a glimpse of the upper atmosphere without revealing the secrets hidden deep below. The space age brought new hope, as probes like Voyager gave us our first close encounter with this majestic gas giant. Scientists initially thought the planet was gas all the way down, with perhaps a small, solid rock hidden at the center. However, a dramatic turning point occurred in 1994 that would forever change our understanding of this massive planetary system. The comet was torn apart by Jupiter's immense gravity, creating a train of fragments destined for a violent collision course. Astronomers around the world turned their telescopes towards Jupiter, anticipating a cosmic fireworks display on a scale never seen before. When the fragments struck, they unleashed energy equivalent to millions of nuclear bombs, scarring the face of the giant planet. These impacts left dark scars in the clouds that remained visible for months, serving as a probe into the lower atmosphere. Fortunately, the Galileo spacecraft was en route to Jupiter and had a perfect vantage point to observe the aftermath directly. The data collected from the impact plumes revealed surprising chemical signatures, including the unmistakable presence of water deep inside the clouds. This was the first concrete evidence that Jupiter holds vast reservoirs of water, hidden beneath its thick upper deck of ammonia. To confirm these findings, Galileo released a small probe that plunged directly into the planet to taste the atmosphere itself. As it descended, the probe transmitted invaluable data for 58 minutes before being crushed by the immense pressure of the deep. It measured winds stronger than any hurricane on Earth and detected intense lightning storms that illuminated the dark, dense clouds. Although the probe was eventually destroyed, its sacrifice provided the first direct measurements of the conditions inside a gas giant. We learned that Jupiter is not a simple ball of gas, but a complex, stratified world with dynamic weather systems. The visible surface consists of ammonia ice clouds, forming the white zones and reddish belts we see through our telescope. Beneath the white ammonia lies a layer of ammonium hydrosulfide, which creates the distinctive brown and orange colors of the planet. Deeper still, we find clouds of water vapor, where massive thunderstorms rage, dropping hail made of an ammonia-water mixture. Scientists call these strange hailstones mushballs, a slushy mix that transports ammonia deep into the lower atmosphere of Jupiter. Here, lightning strikes are frequent and powerful, driven by the heat rising from the interior and the convection of water. Surprisingly, this entire weather layer is only about 50 kilometers deep, a mere skin on the massive body of Jupiter. Dominating the southern hemisphere is the Great Red Spot, a storm so vast it could swallow the entire Earth whole. Recent gravity measurements reveal that this storm is not just superficial, it extends hundreds of kilometers into the planet's interior. The roots of this storm tap into the internal heat of the planet, which powers the ferocious winds that spin endlessly. Interestingly, the spot is shrinking, leading astronomers to wonder if this centuries-old storm might eventually disappear from the face of Jupiter. As we leave the weather layer and descend deeper, the sunlight fades away completely, and the pressure begins to skyrocket. At a depth of 1,000 kilometers, the pressure becomes so intense that it mimics the crushing weight of the deep ocean. Here, the familiar gas laws of physics are pushed to their limits as the hydrogen atoms are squeezed tightly together. We enter a state of supercritical fluid where there is no clear boundary between gas and liquid, just a thickening soup. Eventually, the hydrogen transitions completely into a liquid state, forming the largest ocean in the solar system, made of hydrogen. This is not an ocean of water, but of liquid hydrogen, heated to temperatures hotter than the surface of the sun. Within this liquid hydrogen, droplets of helium condense and rain down towards the core, releasing even more heat energy. Descending further to 10,000 kilometers, the pressure reaches 2 million atmospheres, crushing anything that dares to venture this deep. Under this unimaginable crushing force, the hydrogen atoms can no longer hold on to their electrons and the structure breaks down. The liquid hydrogen undergoes a radical phase change, transforming into a state of matter known as liquid metallic hydrogen. This exotic substance behaves like a metal, capable of conducting electricity and heat with high efficiency in the deep interior. The swirling motion of this conductive metallic ocean generates the powerful magnetic field that surrounds and protects the planet. Jupiter's magnetosphere is the largest structure in the solar system, so vast it would appear larger than the moon in our sky. NASA's Juno mission has been mapping this magnetic field, revealing that it is lumpy and uneven, unlike Earth's dipole field. This magnetic shield is 20,000 times stronger than Earth's, trapping lethal radiation belts that would fry any electronics. We push onward through the metallic sea, approaching the most mysterious and debated region of the planet, the core. For decades, we imagined a solid ball of rock and ice sitting quietly at the center, distinct from the layers above. But the precise gravity measurements from Juno have shattered this image, suggesting the core is fuzzy, not solid or sharp. Instead of a solid rock, the core is likely a diffuse soup of heavy elements dissolved into the metallic hydrogen. Imagine a core that has eroded over billions of years, spreading its material outward across nearly half the planet's radius. The temperature here soars to over 20,000 degrees Celsius, driven by the immense pressure and residual heat of formation. What could have caused this solid core to dissolve and spread out? The answer may lie in a violent ancient collision. Simulations suggest that a massive planetary embryo, 10 times the mass of Earth, may have smashed head-on into young Jupiter. This cataclysmic impact would have penetrated deep into the interior, shattering the original solid core into a billion pieces. The energy of the crash mixed the heavy core materials with the lighter hydrogen, creating the diluted core structure we detect today. It took billions of years for the planet to cool, but the scars of that impact remain hidden deep within its heart. So, as we retreat from the core back to the surface, we realize Jupiter is truly a world of liquid, not gas. From the thin weather layer to the deep liquid ocean and the metallic mantle, it is a fluid masterpiece of nature. This liquid giant rules over a system of diverse moons, some of which may harbor oceans of water and potential life. Jupiter's immense gravity acts as a shield, deflecting comets and asteroids that might otherwise threaten life on our own planet. It is a guardian and a mystery, a planet that bridges the gap between a failed star and a successful world. The Juno mission continues to send back data, and every bit of information peels back another layer of this cosmic onion. Yet, many mysteries remain, such as why the clouds change color and how long the Great Red Spot will truly survive. Looking up at Jupiter in the night sky, we now know we are looking at a vast, dynamic ocean of liquid metal. It is often said that Jupiter is a failed star, lacking only the mass to ignite nuclear fusion in its core. If it were 80 times more massive, it would have ignited, and our solar system would have had 2 suns today. But instead, it remains the king of planets, a unique laboratory for high-pressure physics that we cannot replicate on Earth. The auroras at its poles are a constant reminder of the powerful electromagnetic interactions happening deep within its metallic belly. Jupiter also sings to the cosmos, emitting powerful radio waves that can be detected by simple radio telescopes here on Earth. Future missions like the Europa Clipper will visit this system again, not just for the planet, but for its intriguing moons. By studying Jupiter, we learn about the formation of giant planets across the galaxy and their role in harboring life. We have discovered thousands of Jupiter-like planets orbiting other stars, making our own giant a key to understanding the universe. Imagine standing on the moon Io, watching the volcanoes erupt with the massive, swirling face of Jupiter filling the sky. The gravity of the giant is so strong, it stretches and squeezes its moons, heating their interiors and driving geological activity. Jupiter is not just a scientific subject, it is a masterpiece of fluid dynamics, a chaotic painting that never stops moving. At the poles, we find stable geometric patterns of cyclones, a puzzle of fluid mechanics that challenges our best supercomputers. We have traveled from the ammonia clouds, through the lightning storms, into the liquid deep, and finally to the dissolved core. The evidence is clear. The term gas giant is a relic of the past. Jupiter is truly a liquid metal planet. Science is a journey of constant correction, where new data forces us to rewrite the textbooks and expand our horizons. Even with all we know, Jupiter keeps some secrets for itself, hidden under layers of pressure we can never physically visit. We owe our knowledge to the robotic explorers that braved the radiation and distance to be our eyes in the dark. As the shepherd of the solar system, Jupiter continues its silent watch, orbiting the Sun once every 12 Earth years. Every swirl, every band, and every storm tells a story of physics and chemistry playing out on a galactic scale. If you enjoyed this deep dive into the liquid heart of Jupiter, please support our channel by hitting the subscribe button. Join us next time as we might explore the rings of Saturn or the icy depths of the outer solar system. Thank you for watching Dark Sky Dive, where we make the mysteries of the universe accessible to everyone, everywhere. Keep looking up at the stars and never stop wondering about the incredible worlds that share our little corner of space. Let us take a moment to reconsider the atmospheric pressure, which increases exponentially as we descend through the cloud decks. High above the visible clouds, the thermosphere heats up unexpectedly, another puzzle that scientists are still trying to fully explain. Methane gas in the upper atmosphere absorbs sunlight, creating a warm stratosphere similar to the ozone layer here on Earth. The zonal winds blow in opposite directions at different latitudes, creating the shear forces that generate the iconic swirling eddies. Unlike Earth, where storms lose energy over land, Jupiter has no solid surface, allowing storms to rage for centuries. The colors likely come from sulfur compounds and complex organics called tholins, cooked up by ultraviolet light from the sun. Despite its size, Jupiter is the fastest spinning planet, completing a full day in less than 10 hours of time. This rapid rotation causes the planet to bulge significantly at the equator, giving it a noticeably squashed spherical shape. If you could stand on the cloud tops, you would feel 2.5 times heavier than you do now. The environment near Jupiter is hostile, filled with high-energy particles that form the most intense radiation belts in the system. The moon Io constantly spews volcanic gas into space, feeding the radiation belts and creating a donut-shaped plasma torus. Spacecraft must be built like tanks, with heavy radiation shielding to survive even a few passes near the giant. Jupiter also has a ring system, though it is faint and made of dark dust, unlike the icy rings of Saturn. These rings are created by dust impacts on small inner moons, constantly replenished as old dust spirals into the planet. While Saturn's rings are like sparkling jewels of ice, Jupiter's rings are more like smoke, dark and difficult to see. Infrared telescopes allow us to peer through the upper haze, revealing the glowing heat from the deeper layers of the atmosphere. We observe strange hotspots where the clouds clear up, allowing heat from the deep interior to escape into space. The global circulation of Jupiter involves rising cooling gas in the zones and sinking warming gas in the dark belts. Determining the exact amount of water in Jupiter is crucial, as it holds the key to how the planet formed. A high water content implies that Jupiter formed farther out, gobbling up icy debris rich in oxygen during its birth. Some theories suggest Jupiter migrated inward towards the Sun before moving back out, scattering asteroids and shaping the inner planets. In its youth, Jupiter was likely a cannibal, consuming other small planets to gain the mass it has today. Its gravity prevented a planet from forming in the asteroid belt, leaving us with a ring of debris instead. Jupiter will remain a stable giant for billions of years, long after life on Earth has evolved or moved on. When our Sun eventually dies and expands, Jupiter may lose some atmosphere, but will likely survive as a lonely wanderer. While the moons are promising for life, the planet itself is likely too hostile, with no solid surface to support biology. Astronomer Carl Sagan once imagined giant floating creatures in the clouds, but we have found no evidence for such beings. Jupiter serves as the ultimate physics laboratory, testing our understanding of matter under conditions impossible to create in earthly labs. Understanding metallic hydrogen could revolutionize technology on Earth, potentially leading to room-temperature superconductors if we can synthesize it. So remember, beneath the gas clouds lies a world of liquid wonder, a metallic ocean hidden in the darkness. Studying giants like Jupiter teaches us humility, reminding us of how small and fragile our own world truly is. We leave you with these stunning images, a testament to the beauty and violence of our solar system's king. Let the grandeur of the giant planet inspire you to keep exploring, learning, and looking deeper into the unknown. From the crushing depths of the metallic ocean to the swirling storms above, Jupiter is a masterpiece of nature. Special thanks to the space agencies and scientists whose tireless work makes these virtual journeys possible for us all. Don't forget to like this video and share it with fellow space enthusiasts to help our community grow larger. Check out these other videos on the screen to continue your journey through the cosmos with Dark Sky Dive. This has been a production of Dark Sky Dive. We bring the universe to your screen, one planet at a time. As we pull away, Jupiter becomes just another point of light, silent and watchful in the vast cosmic dark. Thank you for watching, and until next time, keep your eyes on the skies. Goodbye from Dark Sky Dive.